Lesson 5.4 is called Sum and Difference Identities for Sine and Tangent. So again, we have some formulas that we need to memorize for this section. If we are looking for sine of A plus B, formula we need is sine of angle A plus cosine of angle B plus cosine of angle A plus sine of angle B. And similarly, if I need sine of angle A minus B, I will need sine of angle A times cosine of angle B minus cosine of angle A times sine of angle B for the sine function. Tangent function, if we need to find the tangent A plus B, the formula is tangent A plus tangent B all over 1 minus tangent A times tangent B. For tangent A minus B, we will need tangent A minus tangent B all over 1 plus tangent A times tangent B. While you're solving the homework questions, you're very welcome to write these formulas on a piece of paper and use them until you learn how to use them without a piece of paper. So for this question, sine of 75, very similar to the previous lesson, we know that 75 is sum of 45 plus 30. So we can change this problem as sine 45 plus 30. That's what we need. So the formula now requires sine 45 times cosine of 30 plus cosine of 45 times sine of 30. Using our unit circle knowledge, we know that sine 45 is root 2 over 2 and cosine of 30 is root 3 over 2. Cosine 45 is root 2 over 2 and sine of 30 is 1/2. So when I multiply these two fractions, that gives me root 6 over 4. And when I multiply these two things, they give me root 2 over 4. And I can write them together as root 6 plus root 2 over 4. And this is how I can solve this question using the sum identities for sine function. If we model the formula for tangent 7 pi over 12, if we can recognize that 7 pi over 12 is sum of pi over 3 plus pi over 4, this will allow us to change this to an equivalent expression as tangent pi over 3 plus tangent pi over 4 all over 1 minus tangent pi over 3 times tangent pi over 4. So tangent pi over 3 is root 3, but tangent pi over 4 is just 1. All over 1 minus tangent pi over 3 is root 3, but this time we're multiplying by tangent pi over 4, which is 1. So the numerator stays the same, root 3 plus 1 over, and then in the denominator, we have to do the multiplication first, but multiplying by 1 will give us just the same radical. So the denominator is 1 minus root 3. We can't leave our answer like this, so we have to rationalize the denominator. To rationalize the denominator, we have to multiply top and bottom by 1 plus root 3. And then we have to use FOIL to expand the numerator and denominator. And that's what we're going to get at the top, and this is what we're going to get at the bottom. When we FOIL root 3 plus 1 by 1 plus root 3, and 1 minus root 3 by 1 plus root 3. So when we combine our terms, 3 plus 1 makes 4, root 3 plus root 3 makes 2 root 3. And 1 minus 3 will return me a negative 2. And then when we divide 4 by negative 2, that gives me a negative 2. When we divide 2 root 3 by negative 2, and that also gives me a negative root 3. We also have this question type under 5.4, just like the previous section. When we have this formula, we have to recognize that here the first angle is angle 40, and then the second angle is 160 degrees. And then the order is because sine, cosine minus sine. We know that this whole thing is not gonna, it doesn't belong to the cosine function, but it belongs to the sine function. And it's actually sine A minus B, and A is 40 degrees, and B is 160 degrees. So this is the same thing as sine of negative 120 degrees, because when I subtract 160 from 40, that's the angle I get. Sine is an odd function, so when this angle is a negative angle, this negative will go outside, and then it will be the same thing as negative sine of 120 degrees. I will copy my negative. Now I need to find the reference angle for 120. The reference angle for 120 is 60. So sine 120 is the exact same thing as sine 60, and sine 60 is equal to root 3 over 2. So the expected answer for this question will be negative root 3 over 2. And this is our famous question type, just like the previous problem. We have two angles, angle A and angle B. For angle A, we know that the sine of angle A is 4 over 5. So we need to find the cosine of angle A. But there's a detail here. Angle A is located in quadrant 2 because pi over 2 is less than angle A and angle A is less than pi. So angle A is located in quadrant 2. In quadrant 2, cosine values are negative and sine values are positive. So its sine value is positive, but its cosine value must be a negative number. That's what this information tells me. And then for angle B, its cosine value is given, so we have to find its sine value. And cosine B is given, so I need to find the sine angle B. And this question tells me that angle B is between pi and 3 pi over 2. So angle B is in quadrant 3, and in quadrant 3, sine values are negative. And for both of the angles, we have to draw a triangle, and this is my angle A. Its sine value is 4 over 5, so its opposite is 4, and its hypotenuse is 5. Using the Pythagorean theorem, we know that its adjacent side is 3. And all I need from this triangle is I need to find the cosine of angle A. So cosine of angle A is adjacent over hypotenuse. So it's negative 3 over 5. Cosine of angle A is negative 3 over 5. That's all I need. I do not need this triangle anymore. I can clean it in an open space. Similarly, we have to draw a triangle for angle B this time. We have to make sure that it's a right triangle. For angle B, cosine value is given as 5 over 13. So its adjacent side is 5, hypotenuse is 13. Using the Pythagorean theorem, we know that its opposite side must be 12. And we figured out that it needs to be a negative value because angle B is in quadrant 3. So sine of angle B is opposite over hypotenuse, so it's going to be negative 12 over 13. And I do not need the triangle anymore. I drew it because I needed to figure out the sine of angle B. Once we have the sine value of sine value and cosine value of angle A, and sine value and cosine of angle B, the rest of them is just a formula application. Sine of A plus B, the formula says we need sine of angle A times cosine of angle B plus we need sine of angle B times cosine of angle A. The sine of angle A is given in the problem as 4 over 5. Cosine of B is given in the problem as negative 5 over 13 plus sine of B, I found it as negative 12 over 13, and cosine of angle A, I found it as negative 3 over 5. So if I simplify this, positive times negative is negative, and 4 times 5 is 20. 5 times 13 is 65. Here, negative times negative is positive, so 12 times 3 is 36, and 13 times 5 is 65. And when I add them up, that gives me 16 over 65. So the first part in this problem, sine of angle A will return me 16 over 65 for this question. Now, we are going to now find the tangents A plus B. For tangent A plus B, part B, tangent of A plus B, the formula says I need tangent of angle A plus tangent of angle B all over 1 minus tangent of angle A times tangent of angle B. So here we only have the sine and cosine value, but I mean, I think it will be smarter if I didn't delete my triangles because it will be a lot easier to find the tangent values. But tangent of angle A, I can find that tangent is always sine over cosine. If you divide 4 over 5 by negative 3 over 5, the tangent value for angle A will be negative 4 over 3. Similarly, when I do sine over cosine for angle B, this is the sine value, this is the cosine value. 13s will cancel out, and negative over negative will be positive. So the tangent B is 12 over 5. You could use the right triangle we drew here because tangent is opposite over adjacent. You will find still the same ratios with me. You just have to make sure that angle A is in quadrant 2, so the tangent is negative. Angle B is in quadrant 3, so the tangent value is positive. Once we find the tangent value for these angles, tangent angle A is -4/3 plus tangent of angle B is 12/5 all over 1 minus, this is my tangent A, which is -4/3, and then this is my tangent B, which is 12/5, and I have to just simplify my problem. 4/3 and 12/5. I need to get them in common denominators, so I will have to multiply this one by 5 and this one by 3. So this one becomes a -20/15. And then this one becomes 36/15. And then this one is 1 minus, that's -48/15. And then when we combine the numerators, that's 16/15. And here, two negatives, they will give me a plus. So one is 15/15. And when we add the 15 and 48, that's almost a 50. That's 63/15. And 15s will cancel each other. So that gives my tangent value to be 16/63. Now, the next question here is, we can just erase all this work that we got here, or they can stay, I don't know, here. Now the third question is quadrant of A plus B. So in order to answer this question, its sine value is positive, its tangent value is positive. If you remember the riddle I showed you, add sugar to coffee. So everybody is in positive in quadrant 1. So far I have the sine value and tangent value to be positive in quadrant 1, but I doubt that A plus B is in quadrant 1 because this is a quadrant 2 angle, this is a quadrant 3 angle. Here, add sugar to coffee. So here, sine is positive, but tangent is not positive. So it's definitely not this quadrant. It's definitely not this quadrant because in quadrant 3, sine values are negative. It's in quadrant 4, sine value is negative. So it cannot be quadrant 4. So the only possibility is when we add them up, I think they will end up in quadrant 1 because sine and tangent, both of them are positive only in quadrant 1. And this is how we do these questions when we see them in the homework. This will, this is the solution to our question that we got the exact same answers. This will be end of our presentation. Now we're going to quickly look at the homework. And then for the homework, I will not show you every question, but I'm going to model some of the questions. We have a matching problem. We will match the formulas for sine of angle A plus B and sine of angle A minus B, and for tangent A plus B and tangent A minus B using these equivalent expressions. You know how to match them. For question 2, again, it's a matching problem. So you will recognize that the sine 135 times cosine of 60 plus cosine 135 times sine of 60 is the equivalent of sine of 135 plus the 60. And then if we add these two numbers, we will get angle 195. So this will be the same thing as sine of 125. So this is going to come to this box. For this one, the order is sine, cosine, and the sign is minus. So I know that this is still sine, and angle A is 135, angle B is 60. So this time it will be 135 minus 60. And 135 minus 60 is 75. So this will be the exact same thing as sine 75. So sine 75 will be copied here. This is the formula for tangent A plus B, right? And then here A is 2 pi over 3 and B is pi over 4. And when you add these two angles but getting them in common denominator, so this is 2 pi over 3 and this is pi over 4, their common denominator is 12. So we have to multiply the first one by 4, the second one by 3. So this one becomes 8 pi at the top, and this one becomes 3 pi at the top, and the common denominator is 12, and that's 11 pi over 12. So this number 7 is going to take tangent of 11 pi over 12. So the last one has to take whatever is the leftover. Number 3 is pretty simple. Using the sum and difference formula, you can just find the value for sine of 165. You just have to think 165 is sum of what two famous angles? Same thing for tangent 15. It's very easy. You will find the equivalent, and they even have you on the homework that 15 is 60 minus 45, and they help you to figure out this first part. You just have to match it with the correct formula. For number 5, if it is sine cosine, we know that this is a sine problem because the cosine is cos cos and sine sine. So this is sine, and the first angle is 72, and the second angle is 27, and it has to be a minus because we have a minus in the problem. You just have to find this subtraction and find the exact value for sine of that angle. For number 7, this looks like tangent A plus tangent B. So angle A is 86 degrees. Angle B is 94 degrees. So let's just find A plus B because this expression is tangent of 86 plus tangent of 94. So when I add these two angles, that is going to be 180. So I know that this whole thing is just simply equal to tangent of 180, which is sine of 180 over cosine of 180. Sine of 180 is 0. Cosine of 180 is -1. When we divide 0 by -1, we simply get a 0 for this question. And then this will be the last one I'm modeling from the homework. We have two angles, angle S and angle T. For this angle S and angle T, we want to first evaluate sine of angle S and sine of angle T. Then we want to evaluate the tangent of angle S and S plus T. And we want to find the quadrant. We already did a question like this, but we're going to review it one more time. If this is for angle S, so let's just draw the triangle for angle S. And then this is my angle S. Its cosine is 8 over 17, so its adjacent side is 8, hypotenuse is 17. I know the missing side must be 15 because 8, 15, 17 is a spatial right triangle. If its cosine S is given as 8 over 17, I must find its tangent value, sine value. Sine value is opposite over hypotenuse, 15 over 17. And then they are both in quadrant 4. In quadrant 4, sine is a negative value. So I have to make sure that I'm copying the right sign for sine. We can also find the tangent of angle S because I know that I'm going to have to use this for part B. And tangent S is opposite over adjacent, so it's 15 over 8. Again, in quadrant 4, tangent is a negative value. We must draw a triangle for angle T as well. For angle T, cosine is given. If cosine is 4 over 5, adjacent side is 4, hypotenuse is 5. That makes my opposite side to be 3. So I know that now cosine of T is given as 4 over 5. So we have to locate the sine of angle T. Sine is opposite over hypotenuse, so this is 3 over 5. And then angle T is in quadrant 4. So sine value is negative in quadrant 4, so we're going to have to copy a negative value. And tangent of T is still a negative value in quadrant 4, and tangent is 3 over 4. Now, for the first problem, sine of S plus T. The formula says we need sine S times cosine of T plus, then we need sine of angle T times cosine of angle S. Order might be opposite, but for multiplication, it doesn't matter. And then you have the values from here, negative 15 over 17, and then cosine of T is 4 over 5. We'll have to multiply them first, and then plus sine of angle T, that's negative 3 over 5, and cosine of angle S is 8 over 17. So do the multiplication first and then add those two fractions. You will get the answer for part A. For part B, you're going to need tangent S plus T. So you need tangent of angle S plus tangent of angle T all over 1 minus tangent of angle S times tangent of angle T. We already figured out the values for each angle. Tangent of S is negative 15 over 8. Tangent of S is, oh, this is tangent of S, and this is tangent of angle T, all over 1 minus negative 15 over 8 times negative 3 over 4. So make sure that you multiply these two first, and then combine it with, do 1 minus this, and when you simplify this, you will find the answer. And depending on the sign of the sine and tangent, you will figure out what quadrant S plus T will be located. And this is end of 5.4.